Russian defense firm Zala Aero has reported that its Z-16 reconnaissance drone successfully made its way back to its operators following an attempted interception by a first-person view, FPV, drone. According to company representatives, the unmanned aerial system, UAS, sustained shrapnel damage during the encounter but autonomously returned to its base even after losing its communication link. The manufacturer attributes this resilience to specialized onboard cameras capable of detecting incoming threats and triggering automated evasive maneuvers. The drone's internal systems allowed it to maintain orientation, navigate independently, and execute a controlled landing using a parachute and shock absorption system. Deployed by Russian forces since the onset of the Ukraine conflict, the Z-16 plays a critical role in reconnaissance missions. It provides intelligence on enemy positions, detects concealed military assets, and relays targeting data for artillery and air support operations. The UAV has been utilized extensively, including in night operations over the Kherson region, leveraging its thermal imaging capabilities for precision strikes. The recent FPV drone attack against the Z-16 was captured in footage published on the Weaponsrust Telegram channel. The video showcases the drone executing avoidance maneuvers before sustaining damage. Despite the disruption, the UAV managed to navigate back to its operational unit. Zala Aero has emphasized that its latest drone models are built to function in hostile environments where electronic warfare, EW, tactics and counter-drone measures are prevalent. The Z-16's machine vision system independently detects enemy drones and initiates evasive actions without human intervention, ensuring mission continuity even when communication links are compromised. Zala Aero has highlighted that its engineering team frequently updates the Z-16's design based on real-time field feedback. These enhancements focus on strengthening the drone's control systems, communication stability, and overall durability. The UAV features an electric propulsion system and a flying wing design, with a takeoff weight of 10.5 kilograms and a wingspan of 2,815 millimeters. It is launched via a pneumatic system and lands using an integrated parachute and air shock absorber mechanism. The platform carries payloads exceeding 1.8 kilograms, including high-definition video equipment and advanced thermal imaging sensors. The Z-16 boasts a flight endurance of over 4 hours, a communication range extending beyond 75 kilometers, and an altitude capability between 200 and 5,000 meters. It reaches speeds ranging from 65 to 110 kilometers per hour and can operate in extreme temperatures from -40 degrees Celsius to +50 degrees Celsius, enduring wind speeds up to 15 meters per second. For navigation, it utilizes an inertial system with satellite support, a dual radio rangefinder, and an alternative Zala-designed navigation framework alongside a video-based guidance system. Equipped with artificial intelligence, the Z-16 is designed for advanced target detection and prioritization. The UAV features a secure data transmission link, an autonomous navigation module, and enhanced signal relaying capabilities. Engineered to withstand electronic jamming and radar detection, the drone maintains a low acoustic and radar profile, making it difficult to intercept. Zala Aero asserts that these features enable the Z-16 to remain operational even in environments saturated with electronic warfare threats and anti-air defenses.